This is Mr. Precella, and we're going to continue our discussion of factoring trinomials by actually using factoring to solve a quadratic equation. I believe I've already mentioned in the previous video what a quadratic equation is. A quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0. A quadratic equation has to have an x squared term, and if there's going to always be an x squared term, and if a, b, and c are numbers, there's one number that a can't possibly equal, and that would be what number? 0? A can't be 0. So a formal definition of a quadratic equation is an equation that can be written in the form ax squared plus bx plus c equals 0, but a can't be 0. By the way, I'm defining quadratic, not equation. An equation is a statement that has an equal sign. Okay? Now, if an equation doesn't have an x squared term, just an x, then that's called a linear equation. You may recall that from a previous math class. And the way we're going to use factoring in order to solve quadratic equations is by using the fact that if two things multiply together to give you 0, one of those has to be 0. Looking back at some of these factoring things that we've done in the first two videos, notice these two parentheses, that means times. This times that. The only way two things can multiply together to give 0 is if one is 0. And therefore, our strategy for solving quadratic equations by factoring will be to, first of all, make sure they're written in standard form. By that I mean x squared x constant equals 0. We'll write it in standard form, and then we factor. Now, once you have it factored, you're going to have two sets of parentheses on the left with a 0 on the right, and so the only way these two sets of parentheses can multiply together to give 0 is if one of those is 0. So set each factor equal to 0 and solve. You're basically going to be solving two linear equations. Let's just do an example. So here's one. This is, okay, let me write it down. 5w squared, I can't even see what I'm writing. Okay. 5w squared plus 28w plus 32 equals 0. Y'all can't see it. I'd cut it off. 5w squared plus 28w plus 32 equals 0. Well, this is a quadratic equation. Notice it has a w instead of an x as the variable, but okay, still same thing. And it's in standard form. It's in the form w squared w constant equals 0. So we're ready to factor this. So we're going to factor it, and once we're through with that, we'll set each factor to equal to 0 and solve for w. We're going to have two linear equations to solve. So let's see. If I'm going to factor this, what numbers multiply together to give 5? Well, 1 times 5 is pretty much it, isn't it? And what numbers multiply together to give 32? Oh, there's a lot of those. 1 times 32. 2 times 16, and what else? 4 times 8. Well, I'll draw my two sets of parentheses. And y'all remember what sort of signs are we going to have here? 2 pluses, 2 minuses, or 1 of each? Well, the second sign is plus, so 2 of the first sign, plus and plus. Now, since the only possibility for 5 is 1 and 5, I'm going to go ahead and fill those in right off. Okay? So I'll say 1W times 5W. And it doesn't look like we're going to be able to use common factors here to knock out some, because none of these numbers have a common factor with 5. So I'll go ahead and just try it like this. I'll see if the 4 and W can work. I'll put 4W. If that doesn't work, the 4 and 8. I'll put 4 and 8. If that doesn't work, I'll put the 8 and 4. And then if that doesn't work, I'll move to the 2 and 16. 2, 16, 16, 2. If those don't work, I'll try the 1 and 32 or the 32 and 1. I'm sure thinking that the 1 and 32 can't possibly work because the middle number that we're going to be trying to get is a 28. So let's try the 4 and 8. Well, let's see. I'm making these little marks here, and this is where I'm trying to determine if the inner and outer terms combine together to give a 28. We would have a 20W. 4 times 5W is 20W. 8 times W is 8W. Oh wow, did I get the right one right off? I sure did, didn't I? Okay, so it factors as W plus 4 times 5W plus 8. So we factored it. Now, set each one of these factors to 0. I'll set the W plus 4 equal to 0. And the 5W plus 8 equal to 0. And solve those linear equations. Notice they're linear now. There's no longer an x or a w squared in it. Well, to solve a linear equation, you do the opposite operation to both sides of the equation, beginning with addition and subtraction. I'm isolating the w by subtracting 4 from both sides. And I would get w equals -4. So there's one answer. Now let's come over here. On this one, do the opposite operation beginning with addition and subtraction. So I'm going to subtract 8 from both sides. So on the left I just have 5W. 0 minus 8 is a -8. Now the W is not by itself, so what am I going to do to both sides in order to get the W by itself? Well, this is 5 times W, so the opposite of multiplication is division. So divide both sides by 5. And there we have it. W is -4 or -8 over 5. So -4 -8 over 5. Okay? Not too bad, is it? Let's do another one. Number 11. Let me write it down. T squared plus 4t equals 45. T squared plus 4t equals 45. Well, there's a problem here. This thing is not written in standard form. Standard form has a 0 on one side. I always prefer for this first number here to be positive. Okay, I think it factors easily if you always have that first number positive. Okay, like right here, +5. I've got to have a 0 on one side. This should be written in the form t squared t constant equals 0. That means this 45 needs to be moved over here. You'll notice throughout the semester, my little notation, I'll do this little arrow thing, which means subtract 45 from both sides. Okay? You wouldn't add 45 to both sides, because if you did, you'd get a 90 on the right. Okay? And you want a 0 there. So here's the equation that we're going to be factoring and solving. T squared plus 4t minus 45 equals 0. So it's in standard form. Hey, this one's going to factor pretty easily. There's no number in front of the t, so that makes it a little easier. I'll need numbers that multiply together to get 45. Well, 1 times 45, 3 times 15, and 5 times 9. That's probably what y'all were thinking of right when I was writing 3 times 15, isn't it? Now I'll draw my two sets of parentheses, and I'll put a t times a t. Those are the simple ones to factor, where there's not a number in front of the square. Well, I guess there's a 1. Okay. Now the second sign is minus, so that means there's 1 plus and 1 minus. I'll wait to fill it in. You might wonder why I keep referring to this little chart here, but it tells you everything about those signs. The second sign is minus. There's 1 plus and 1 minus. Wait to fill them in. You're going to have to subtract the outer and inner to get that middle term. So most of y'all can figure out which pair of numbers we're going to be able to subtract to get here real fast. The 5 and 9. And we'd have a 5t and a 9t. If we want a positive 4t, that means the 9 needs to be positive, the 5 negative. So we have factored it, but we're not finished yet. What do we need to do to actually solve this thing for t? Well, take each of the factors, each set of parentheses, set it to 0, and solve for t. So t minus 5 equals 0. To get the t by itself, you would plus 5, add 5 to both sides. The notation that I'll do, I'll just put that little arrow there, which means move that 5 over and change the sign. I'm adding 5, adding 5. Look right here when I do this, what that means is subtract 9 and subtract 9. So negative 9 and positive 5 are the solutions we would have to type in. Negative 9 and positive 5, or 5 and negative 9. It doesn't matter which one you write first. Okay. Let's see. What about this next one? Here's another one for us to do. Problem number 12. Oh, let me start on a clean sheet of paper. 11t plus t squared plus 28 equals 0. Well, the variable's t rather than x, but is it in standard form? No. It has the 0, doesn't it? And the constant? But that t squared term should be written first. So we notice we're not going to change any signs or anything here. You're not moving the 11t across the equal sign. You're switching these and writing it like this. T squared plus 11t plus 28 equals 0. Sometimes students say, well, wait, why aren't you changing the signs? I didn't move the t squared on the other side of the equal sign. I didn't move the 11. So let's see. This is another one that's going to be kind of easy to factor because there's not a number in front of the t squared. So numbers that multiply together to give 28. 1 times 28, 2 times 14 is probably not what you're thinking of. You're probably thinking 4 times 7. Second sign is plus, so 2 are the first. A positive 4, oops, I did put a T in a T. Now we're trying, a positive 4 times a positive 7 would give a positive 28. But when we add them together, positive 4t and positive 7t, that gives us the positive 11t. Y'all getting better at your factoring? So we have factored that one. Set each factor to 0. So we get t equals negative 7 and t equals negative 4. So negative 4 and negative 7 are our answers there. Now, here's another one. Let me write it down. R squared plus 6r equals 27. Well, this one's not in standard form. It doesn't have a 0. We need a 0 where the 27 is. And so I'll just do that, meaning subtract 27 from both sides. So what we're factoring is r squared plus 6r minus 27 equals 0. Now we need numbers that multiply together to give 27. Well, 1 times 27, 3 times 9, is that it? So second sign is minus, so there's going to be a plus and minus. I'll wait to fill that in. I'll put R and R. Do I have a feeling for what pair of numbers is going to work? The 1 and 27 or the 3 and 9? 3 and 9? Now we have a 3R and a 9R. If we want a positive 6R, the plus is going to have to go on the 9, the minus on the 3. And foiling that in our head, have we factored that correctly? Yeah. So set each one of those factors to 0. R minus 3 equals 0, and R plus 9 equals 0. So add 3 to both sides to get R equals 3. Subtract 9 from both sides to get R equals negative 9. So positive 3 and negative 9. You type this in. If you're typing it in on my math app, don't hit any spaces. Just put 3 comma negative 9. Okay? We're just sort of flying through here. Let's see. 10 here this, oh, flip it over. Next one looks like it's going to be more involved. Okay, there's more numbers, if you will. Let me write it down. This is problem number, right, I guess the problem numbers. It's my number 14. These are just some examples. Okay. 18a squared minus 39a plus 20. Well, let's see. First thing we can do is we know that the second sign is plus, so it's going to be 2 of the first sign. So both sets of parentheses will have a minus. Oh, I should mention, it's already in standard form, isn't it? I don't need to move anything around. A squared, A constant equals 0. So let's see. Numbers that multiply together to give 18. There's 1 times 18. 2 times 9. 3 times 6. Numbers that multiply together to give 20. 1 times 20. 2 times 10. 4 times 5. Now remember, you can't have 2 sets of parentheses that have, you can't have a set of parentheses with 2 even numbers in it, for instance. So that might help us eliminate some possibilities. Remember, no common factors in the parentheses. I generally start off with the numbers that are closer together. I'm going to try the 3 and 6 rather than 1 and 18, but that's up to you, how lucky you feel. So I'll say 3a and 6a. Oh, what did I not do? Second sign is plus, so 2 of the first. So we know it's going to be a minus and a minus. May as well fill it in. Now I'm going to try this with the 4 and the 5. Now let me think. I can't put the 5 here and the 4 here, because if I put that 4 there, there's a common factor of 2. Can't have any common factors other than 1. So the only way this could possibly work out would be if the 5 is there and the 4 is there. Well, let's see. Let me see. Let's see. Someone trying to tell me I miscopied the problem, did I? I don't think so. Oh, I see now what you said. I'd already said you can't have a common factor here. That's what you're trying to tell me. Let me rewrite it. See, the 4 and 6 have a factor of 2. What I meant to write was, that's a problem with these videos. You can't just go back and erase minus and minus. So with this 4 and 5, I can't have the 4 there because it would be a factor of 2. The 4 would have to go here and the 5 there. Now let's see, making the little marks for outer and inner, are we going to be able to get the negative 39a for our inner term? Excuse me, for our middle term? Let's see, what would this be? Negative 4 times 6 is a negative 24. 3a times a negative 5 is a negative 15a. Do those add together to give a negative 39a? Yes, they do. So on the first go through, we factored it correctly. Great. Now set each one of these factors to 0. How am I doing up there on the projector? Is it too low? Oh, let me lift it up. So how would I do this? I'd add 4. So that little arrow means move the 4 over, divide, and change its sign. In other words, add 4 to both sides. And then what do I do to cancel out that 3? I divide. I'm trying to get the variable by itself. That's what I'm doing here on this last step. I'm trying to get the a by itself. Whatever I do to get the a by itself, I add 5, and then divide by 6. So 4 over 3 and 5 over 6. 4 over 3, 5 over 6. Okay. And then for the last one, I'll just work it right here. I have all this extra paper. So let's see it. Let me write it bigger so you can see it. 12w squared plus w equals 6. Well, this isn't in standard form. What do we not have? We have a w squared and a w, but we don't have a 0 over there. That means we need to move that 6 over. This little arrow means move the 6 over. That's changing the sign. You're subtracting 6 from both sides. Remember, recently a student asked me, well, why not plus 6 to both sides? Well, imagine if you put plus 6 and plus 6, you wouldn't get a 0 over here. You would get a positive 12. Okay? So I'm subtracting 6. And here's the thing we're going to try to factor. 12w squared plus w minus 6 equals 0. Now let's see. Numbers that multiply together to give 12. There's 1 times 12, 2 times 6, 3 times 4. Numbers that multiply together to give 6. 1 times 6, 2 times 3. I'm going to start with the 3 and 4 and see if I can pair it with the 2 and 3 and get it to work out. Now the second sign is minus, so that means we have a plus and a minus. I'll wait to fill those in. So I'm going to put 3w and 4w. Now, let's try it with that 2 and 3. Well, I can't put the 2 here because there'd be a common factor. The 2 would have to go, if it's going to work, using these numbers, these pairs, 3, 4 with 2, 3, then the 2 would have to go here. There's no factor other than, common factor other than 1. Here there's no common factor other than 1. So let's see, we would have an 8w and a 9w. Can I subtract those and get a 1? That's what this is, a positive 1w. Sure, the 9, the bigger number, would need to have the plus. The smaller number, the 8, would need to have the minus. So that means a minus there, plus there. I was about to say we were finished, but no, we're not yet finished. We've just factored it at this point. We still need to set each one of those factors to 0. How am I doing up there? Do I need to lift it up a little? So, let's see here. 3w minus 2 equals 0. Add 2 to both sides and divide by 3. So 2 over 3. And what's my other one? Move the 3 over. Or in other words, subtract 3 from both sides and divide both sides by 4. So negative 3 over 4 and positive 2 over 3. Okay. that wraps up all of this discussion of factoring trinomials. We were factoring them with trial and error. And then we made some little generalizations, okay, about the second, based on the second sign. And then once we've mastered factoring with trial and error, we started solving quadratic equations by factoring. So next topic in normal algebra is to continue discussing other ways of solving quadratic equations, or at least in most algebra classes. That's what we're going to be doing. So there's some more ways to solve quadratic equations by something like the quadratic formula the next time. So thank you very much for listening. This is Anthony Precella, and have a good day. I'll be talking to you again soon.